Hi, welcome back, everyone. We're still collecting people to get back from the break. The session chair for the panel will be Gabriela Carini, who's also connected. And it'll be up to her when to decide to get going. So I'll just leave it.
We said
Give
we
it to
start
her
at
from now on.
2:05, so maybe a couple minutes
And I
more.
think the captions are also available for those who want them. Thank you.
Can you hear me?
Yes, we
There
can.
you go.
Yes, very
Okay,
well.
good. So we are waiting one panelist. He should reconnect soon. It was the session earlier.
You're muted, Gabriel.
I am?
No, I hear you.
You're speaking, we can't hear you.
So some can and some
Still
cannot
can't
hear
hear.
me. So Maurice, seems that you can't hear me.
I can. Hartmut can. No.
I can too.
Okay, that's interesting. Um, let me try to change.
No, sorry, it was my problem. You're fine.
Okay, let's try this one now. Can you hear me now, Maurice? Or?
Yes, we can hear.
Okay, good.
Yeah, it was okay before. It was just
Okay.
I did something wrong.
All right, so I still don't see one of the panelists, but perhaps we should start. So thanks everybody for joining us for this panel. We had a wonderful session previous to earlier this morning, and we have now the speakers of the session and two additional panelists for this discussion. We will work like we did in the previous days. We will have the panelists to briefly introduce themselves, and then we will start the discussion. So to avoid any distraction, I would share the slides that you previously sent me, and then I will ask you to speak. So let's start with Hartmut.
Are you sharing or am I sharing, Gabriela? Oh, okay, you do. Okay.
I'm sharing, yes. Go ahead.
Thanks. So I forgot to write down that I'm actually at the University of California, Santa Cruz for the last 4 decades. Just wrote down that this work there then resulted in two patents. One of them is actually for the AC coupled LGAD with Nicolo Cartiglia and Abe Seiden. Nicolo used to be a graduate student in Santa Cruz. And I wrote a book because I want to learn about FPGAs. My favorite publication is a paper which Nicolo and Abe wrote about 4D tracking some time ago. And I'm very, I used to be very involved in outreach, and I want to talk a little about that too. I think, Gabriela, you are controlling it. Yeah, next slide. Okay, so I have been involved for quite some time in silicon sensors, and I've tried to highlight here the advances which happened while I was working on it. Early on, we developed actually silicon detectors for the leading proton spectrometer for Zeus at Hera, collaborating with Torino and Bologna. And we actually built a fast binary readout ASIC, this bipolar front, and everybody else was doing CMOS, everybody else was doing 1 microsecond shaping time. We did 35 micron, sorry, for 35 nanosecond shaping time. And we were thinking forward. We were thinking forward to the SSC, and that's why we did this. So this is sort of a pattern that we always went a little further from the point we were to in the future. Then we did worked on the SCT for Atlas for the LHC, and we was very much involved in radiation damage studies. Next came using this technology to work in space for GLAST, Fermi now. We work very closely with Hiroshima University, SLAC, INFN Pisa, INFN Trieste. And we developed with Hamamatsu 6-inch wafers, about 10,000 wafers. And we studied radiation damage in space. Next came use of the same detectors in imaging for proton CT with Loma Linda University Medical Center, and followed by working on the LHC upgrades with RD50, and we supported the idea of using N-on-P sensors instead of the P-on-N, which was used before. And now I'm working with on the ultra-fast silicon detectors with INFN, Torino still RD50, and with Atlas on the high guarantee timing detector. And what is coming out is LGAD and AC LGAD. Next one, please. But I was actually very interested in outreach. We had two programs at Santa Cruz. One was Balloon Fest in Paso Robles in a winery, which increased the attendance by our graduate students and staff. Had about 100 kids coming in and taking data from balloons. Great opportunity to talk with kids and so on. The other one was a visiting program of schools with a Tesla coil. We put the teacher into a metal suit and and zapped him, and that was very attractive for the kids. And we might have be seen by about 20,000 students while we did this. Next one, please. So I'm very interested in interaction and progress. One of the first things we did, which I really liked, was in 1984 and 85. We actually went to IHEP in China to start the detector development of VES. There was a fairly large group from the US, but also from Europe, and I think we still are friends. Everybody is friends after all this time. I'm very interested in working in the group in Santa Cruz on silicon development. I'm very active in traveling all over the world to catch special fish like this golden mahseer in India. That's it.
I am Steve Holland of Lawrence Berkeley National Lab. Next slide. I've been there 33 years. My research interests are in semiconductor detectors and technology. As we discussed this morning, I go back to the SSC days. And of course, the work lately has been mostly on fully depleted CCDs. My graduate work was at UC Berkeley Electrical Engineering Department. My research advisor was Chen-Ming Hu. Publications are at this Google Scholar page, which is the total extent of my social media footprint. When my friends ask me if I have a Facebook page, I direct them to my Google Scholar page. I gave a talk this morning, probably most of you heard it, on CCD technology development. And then the next slide was actually from that talk, and just kind of summarized the work that we did with industry. And also, let me point out the work that we do with Fermilab. So both the dark energy camera and especially these days, this novel Skipper CCD with single electron detection capabilities, that's all collaboration with Fermilab. So.
Hi, so should I go ahead? This is Juan. Can you hear me?
Yes.
We can hear you.
Okay, sorry, I have some problem with my computer, but I'm using my phone, so I hope it works. So I am a scientist in the astrophysics group. I work mostly on direct dark matter detection with low threshold CCDs, the Skipper CCD that Steve was mentioning in his talk, right? That's the tool that we use for our work with direct dark matter. I also work with this type of sensors on other efforts in QIS and SEVENS and do some other detector R&D for astrophysics. So during the last decade, I was involved heavily on the dark energy camera, and then more recently on DESI, the dark energy spectroscopic instrument, always on the focusing on the sensor part. And before that, I worked on the mass of the top quark in the Fermilab Collider program. So I put a list of the collaborations that I participate on. All of them are using the sensors that Steve mentioned that are developed at LBL and DOLSA. So all the stuff that Steve has been doing is the basic tool that I use in all my research. So if you go to the next slide, please. Okay, so my relations with industry are not as extensive as what other people have presented here, but I have some things that work for me, right? So the first that I wanted to mention is small companies for engineering support, and this has been very productive, right? One example is what we are doing with a company in Illinois called CU Aerospace. It's a local company that develops small satellites. So we are working with them on a CubeSat for dark matter that is called Darkness. So they have their own engineers, but they also hire engineers part-time or student engineers from UIUC, from University of Illinois at Urbana. And we are collaborating with that group in our science, right? So it's very interesting because we benefit from the relation that this small company has with the engineering group there. We don't have to hire the students as engineers here, they hire them. It's much easier, right? And we are doing the same with other companies outside the US where they have good relations with engineering schools that are our collaborators in these dark matter and CCD projects. And then we use them in our experiments. So they participate on design of prototypes and things like that, very closely to the Fermilab engineers. And then in the science, we collaborate all together with the institute that is partnered with them. So it is very, it has been very productive. This seems like a good way to leverage the existing partnership between the universities and the industry. Is a lot easier than hiring engineers directly at Fermilab for a short time, right? And it is very practical with the minimal travel that is imposed by the COVID conditions now, right? So in addition to that, we are also working with a smaller company that also came out of the university that is called Q-Tools, and they are willing to change some of the products that they sell to accommodate our needs for quantum imaging with skipper CCDs. So go to the next slide, please. Okay, so what has not worked, and I have to say that I didn't plan this with Steve, but it has been unreasonably difficult and expensive setting up CCD fabrication contracts with the industry, right? So the way it works for us is that between Fermilab, LBNL, we have to move the money and do the contracts with the foundries, and this has been very, very hard, right? It takes a year, and we end up going through distributors that add bureaucracy only, right? And take a significant chunk of the funding. So I'm not sure if there is a real solution for this, but long term, this is a non-technical issue. So for us, we, going on now, we are doing skipper CCD experiments that are much larger than what we have done in the past. So in the past, all our dark matter and neutrino efforts had at most 50 sensors, actually less than that in most cases. And now we are planning experiments with 10,000 sensors. So this is a significant scale up from what we have been doing until now. And the method that we have been using for assemble electronics, package and test do not scale up. So we're really trying to engage companies in this large-scale fabrication process. When we started talking with these companies, with some of them, we realized that they already have worked with US CMS, so in high energy physics efforts, right? So one question that I will have is that it will make sense to establish some kind of database for the companies that have already contributed to high energy physics experiments to facilitate this information exchange across experiments, right? I'm sure that as we are going through this process of identifying the companies that can help us build the experiment, we could benefit from the experience from previous colleagues. Okay, so that's all I had to say for my introduction.
Thank you. So I then ask Toki to introduce himself.
All right, thank you for showing my slide. Right, so my name is Aritoki Suzuki. I'm a staff scientist at the LBL. This is my third year as a staff scientist, but I've been at the Berkeley area forever. I got my undergraduate, graduate, and postdoc, all that at the UC Berkeley and LBL. I love it there. So my training as a graduate student and a postdoc was in this area of making superconducting detectors and the readout electronics for cosmic microwave background, and now extending that to other high energy physics and recently quantum information science experiments. So I do design, both electromagnetic simulation, layout, and I think through the fabrication steps. I have done microfabrication myself quite extensively, and then millikelvin level of a cryogenic characterization. And then because cosmic microwave background is not just a detector, it has telescope with lens and optics and everything. I'm also heavily involved in material characterization for the around the 100 gigahertz range at the cryogenic temperature. There's not that much literature in that temperature range, so we have to do all that ourselves, but that's a good opportunity to write a paper as well. If you can go to slide 2, please. Thank you. I like working with commercial partners, and this is actually not all the project that I worked on. This is actually only a subset. I've been working with a commercial partner, seek to fabricate a superconducting detector for cosmic microwave background. I also worked with a company called Star Cryo Electronics to fabricate a squid amplifier. So this is a superconducting amplifier used to read out transition edge sensors. Then there's a company in Colorado called Quantum Design that can machine silicon, just a block of silicon really well, and then make silicon lens array that you see there. And I should have put the scale there, but each one of those hemisphere is about a 5 millimeter or the 1/4 inch in diameter. So quite a small object. That screw right there is 0.80. So kind of give you a scale. Then the bottom right is that, so those silicon lenses do reflect light if it's not properly anti-reflection coated. And so this is actually the project we worked with a foreign partner, and we made this glass dome and then put it onto these silicon lenses to act as a contact lens or anti-reflection coating. That also worked well. So various projects kind of hovering around 100 gigahertz frequency range and at the ultra low temperature.
Thank you. Then I'd ask Anna. Anna, please.
Hi, good afternoon. So this is Anna Pladalmau, and I'm also a scientist at Fermilab. My background, though, is in chemistry, and I've always worked in different projects and aspects, but always from the basically chemistry standpoint. I focus, my work is in plastic scintillators. I've been at Fermilab also 30 plus years, and that has given me a chance to work on things related to R&D, then also participate in projects, and more recently in fabrication. And we've worked with industry to fabricate certain scintillators or components, and we are now also are making our own plastic scintillator, extruded scintillator. As R&D, although we started looking like at different dopants for the plastics and also trying to answer questions related to radiation damage. In a way, these are topics that go back and forth, but we never are completely put away or put to rest. There's always something new to try. At some point, because of the size of the detectors, in a way, when the neutrino experiments at this point, 20 years ago, actually at the point we started was maybe even 25 to 30 years ago, it was obvious that they were, that plastic scintillator could be feasible if we could really lower the price it had for, again, for neutrino experiments. So we started looking into fabrication techniques that could bring the cost down. And that's how we ended up looking into extrusion. And just more recently, we've started to look into injection molding, although the interest has been there for a while. So back to before late 90s, then that was when the Minos experiment was being discussed and was being basically baselined, and the plastic scintillator was going to be extruded. So at the time we went to industry and discussed it with them. We had started our work in probably early mid 90s, and we would go to the industry and basically rent an extrusion line for a day. And so that was expensive. Probably each test was of the order of $15,000, $20,000. So we probably had one a year. Anyway, we had made enough progress that it was a viable process for Minos. And then we looked into really having the production there. So that was my first experience. And although Minos was a large amount, and I think it was of the order of 300,000 pounds, it really, sorry, that could be actually 300 metric tons. So it wasn't really that much for the industry. And it was hard to actually get a company of the right size that could fabricate it. But we did, and it got built. Fermilab did all the QA of the materials and the QC of the extruded product. And in a way, we were there other than running the line. Luckily, it was a local company, and we were very hands-on. After that, the company was not interested in really pursuing it. At some point, actually, was not interested even in doing a smaller orders that we had. And luckily, through a collaboration with Northern Illinois University, they got an extruder, actually a full extrusion line, which is the picture in the center. That was around 2003. And we installed this line at Fermilab. And then further equipment came along, and then we have been making extruded scintillator for Fermilab experiments and tests around the world. And these are the shapes that you see on the upper left corner. that's some of these shapes are the ones that Minos used, and Minerva and Mu2E and many other experiments all along. With NOVA, I was the project chemist, and I really enjoyed it, I should say, but also gave me the opportunity to work in more than one thing. And NOVA has liquid scintillators, so then the plastics end at that point was basically the container that was going to hold the liquid scintillator. So we looked into the PVC and basically learned how to make really as reflective a PVC as we could, and found a company, worked with a company then with two companies, one to make the PVC resin and one to actually make the extrusion. And the experience there was that, again, with lots of supervision, lots of hands-on, it was a big success. The biggest problem sometimes is for the plastic industry to realize that it's in the end, it's an optical component, so that it's not enough that it has a perfect shape. It really needs to have, for example, as much reflectivity as it can be. So, and in NOVA, for example, it also had an structural component that had to be met. So it was very hard, and actually it was costly to make the company realize that even if the specifications were met, that there were other more subtle things that had to be considered and made sure that they were correct. So that, for example, in the NOVA part, that all the need lines, all the intersections of the different plastic flow in the different directions, that would be all fully fused, and that it was structurally sound. And that was very hard, because they wanted to go into production when we were still asking them to let us run more tests and check, and basically, anyway, convincing them was hard. But also then there was the liquid scintillator blending, and that was, again, once we had everything in place, lots of work making sure there were procedures and how we wanted it done, and again, all the intermediate steps to check quality, but it did proceed very smoothly. So, and now the next, I think, looking ahead, the idea is to look into injection molding. And we got a machine also through the NIU collaboration at Fermilab, and we are starting to look into that. The idea here is that now we would like pieces that are smaller components, so that will give more granularity to the detectors. So now injection molding is better suited than an extrusion to make these plastic scintillator elements. Also, for an experiment, for example, a detector for the Dune near detector that would require, I think they are looking into something of the order of 10 or 11 million centimeter cube pieces of scintillator. So obviously the idea here would be more to again, do the R&D work or the basic work at Fermilab, and then this would be something that would be done with a company, with an industry that would have several machines and lots more expertise in production. And I think that kind of wraps up a little bit what I've done through all these years and my experience with the industry.
Thank you for summarizing 30 years on one slide. So let's ask then Ken.
Okay, I'm a materials scientist, came out of University of Wisconsin-Madison when the Applied Superconductivity Center was there. It's now moved to Tallahassee in Florida State. So my focus has been on applied superconductivity, particularly conductors for high field magnets and superconducting magnets for a wide range of applications. So after PhD, I had a one-year appointment at what was then the National Research Institute for Metals in Japan. And it was under the auspices of a US-Japan exchange in fusion energy sciences. So I had the opportunity to visit the Japanese manufacturers of superconducting wire and magnets at the time, and also the Japanese national labs that were working in magnets, both for high energy physics and for fusion. After that, I spent 15 years at Oxford Instruments in industrial superconductor R&D, including development of materials processing and characterization and project management of a variety of large projects, including the wire for the world's first 900 megahertz NMR magnet, which was built in England, but all the wire came out of our New Jersey plant. 6 years at Los Alamos, leading the Superconductivity Technology Center. That was aimed at development of high temperature superconductors, primarily for electric power, but for a whole range of applications. And for the last 9 years, I have been in the Office of High Energy Physics at DOE. So I'm the portfolio manager for the SBIR programs and the program manager for superconducting magnet R&D programs, both at the national labs and the universities. So next slide. So just a high level look at the SBIR portfolio. It includes approximately 75 active projects. It's typically about 40 phase 2 and 35 phase 1. And we have an average annual investment into that area of $24 million. There are more than 50 small businesses involved in the program today. And the topics span the range of accelerator and detector technology. And there are 4 program managers that serve as technical topic managers for specific areas. So we work together on this. And last slide. So here are the FY20 phase 1 topics and the technical topic managers that work with me to do the high energy physics superconducting SBIR program. So John Boger handles advanced concepts, and the last one, which is quantum information science supporting technologies. Eric Colby handles the laser technology and the normal radio frequency stuff, while I handle the superconducting RF stuff. Superconducting magnets are my baby, and then Helmut handles the high energy physics, electronics, and detectors and instrumentation areas. So that's me.
Okay, thank you. So Michelle. Michelle, would you introduce yourself?
Hello, everyone. Hi, so I am truly going to give a brief bio. I've been listening with great interest with my colleagues. And so if you'll go to I'm just going to do one slide and talk to that. I was born and raised in Oklahoma, attended Oklahoma State University in Stillwater, and received all 3 of my degrees there, as I kind of preferred to be a big fish in a small pond rather than a small fish in a really big pond. Back then, when you did solid state physics or now condensed matter physics, that would be like at the University of Illinois. And I got to work under the guidance of the very best professors that way. I chose to work at a national lab, in this case, Lawrence Livermore National Lab rather than postdoc. And there I worked on new laser materials, crystalline and glass, for the National Fusion Program. And then I wanted to work closer with the sort of the growing awareness of the role and the really need to foster greater diversity. So I joined as an associate professor of physics. I joined Bryn Mawr College and ran a successful research program and taught. And that was so I have a lot of I guess I would say, empathy, and also I really resonate with the academic community in that regard. But then people came knocking for my laser expertise, and so I joined the Thomas Jefferson National Accelerator facility, but back then it was called CBAF, which nobody seemed to really be able to pronounce, know what it was. I was Mrs. CBAF. I got letters for CBAS, things like that. But I ran the optics program for the free electron laser and gained a lot of experience beyond what I did with a Van de Graaff at Oklahoma State. I learned quite a bit about accelerators, and we actually developed the highest power to date continuous wave or average power free electron laser in the world. It's 14.3 kilowatts. And but I really, again, wanted to do more, wanted to spread my wings and have a bigger impact in society. So I thought, how could I do that within at Jefferson Lab? Well, one way is to learn more about what happens in the Office of Nuclear Physics, the steward of Jefferson Lab. So I went up there in August of 2013 as a detailee. Got involved with Monisher Fakonde, who was the program manager and portfolio manager of the SBIR program. And then when an opportunity came to for the newly formed industrial concepts position, which is unique at an NSC, I'm totally, well, for the most part, totally devoted to the SBIR STTR program. And I became a Fed in January of 2016. So oddly enough, it's been almost 5 years as a Fed. In the process, I have one of the most amazing portfolios. I get to work on the software side. I get to learn about the software side, data management side, QIS, instrumentation. I've always been big in instrumentation for optics. I really have just dove in on instrumentation for NP. Another thing is, in accelerators, I knew electron sources, but in NP in general, you need to understand ion sources, whether they be electron cyclotron resonance ion sources or electron beam ion sources, sources developed from gas discharge even. Or lasers, pulse laser deposition, but laser ablation is done with the Lion source at the RIC at BNL. So I get my hands in everything, which is really awesome. I'm also a parent. I have a daughter. I'm a public speaker. I speak about a wide range of topics of interest, both in HEP and in NP. Really trying to showcase what DOE science, can do. I'm an amateur astronomer. I'm a beekeeper, and I'm quite an outdoors person. So that's me.
Thank you so much. And so let me stop sharing and start the panel. We have an impressive set of speakers, so I'm sure we will have very good discussion today. I do see a first question in the chat, so perhaps I will start with this. So the question is, as we heard, a close relationship with a vendor is critical to success. What are some issues, COI, etc., between this need and the SBIR rules? Anyone want to start answering that?
Well, I can sort of speak to that to some extent, and I have to say that the SBIR office rules sometimes evolve a little bit. What you really have to know is look through the range of your community, which includes, of course, the academics, and find if you've got a particular issue. Let's say that you, Gabriella, wants a particular ASIC or development. Of course, you make some wonderful ones right there at Brookhaven. that if you needed something, then obviously I can't use you or anybody in your team. And congratulations, by the way, on your promotion. And I'm very, very happy for you. And but you can't use Brookhaven. Well, that's fine. Okay, so I'll go to Berkeley, which also has an incredibly good instrumentation group, or Oak Ridge, or Lannel, or there's folks at University of Virginia. You can start just working through. And then what's really fascinating is that when you do a phase one, and I have these kickoff meetings, so they get to work with the community. Actually, early on, they're with the community. So guess what? They ask for phase two. They ask those people to write letters of recommendation, or they go on subcontract. So all of a sudden, I'm COI and I can't use them. Well, you just juggle. You just juggle. So that's my response. I'd like to hear what my colleagues, Ken in particular, for example, he probably does something somewhat similar.
So, yeah, there's a range of issues here. I'm not sure exactly what Maurice is asking, and the conflict of interest in the review process is, of course, a challenge, but as Michelle says, we can find ways to manage that. Beyond that, once a project is underway, I mean, there are clearly intellectual property issues. And I will say that the DOE rules regarding that are moving toward protecting the company more and more. So they used to have 5-year protection on data and information that they declared confidential. They now have 20-year protection.
Exactly.
So there is a wide variety I have found between companies and how they treat that. So for example, I showed a success story in my talk about advanced conductor technologies. They're very, very open. They work very closely, both with Superpower, who supplies them tape, and with the national labs and with a variety of universities. They in general tend to publish much of their data and information. They do reserve some things, particularly in the processing of their wires and cables. But so there's an example where I think openness between the small business and the broader community has actually contributed strongly to their success. There are others that won't say much. However, that does not prevent them from working in a proprietary fashion with national lab collaborators if they are part of the program. We have examples of cases where they use laboratories as subcontractors, and there are a variety of examples of non-disclosure arrangements and agreements between laboratories and the companies. Although in some cases, I will say that some laboratories have presented non-disclosure agreements that some small businesses would not sign and found unacceptable. So it remains a barrier, but I would say approaching it on a case-by-case business has allowed us to, in many cases, have significant successes despite the barriers.
So I guess the second part of Maurice's question had to do with working with foreign vendors. And the question is, what are some funding challenges of doing development with foreign vendors, and how could they be addressed? Anyone want to start? We heard also from other panelists that they have experience with foreign vendors.
I guess Hartmut has some experience here. I don't know.
Yeah, there is Amamatsu, there are others, right?
Yeah, I mean, I understood that you're discussing SBIR now, right?
Well, I guess the question about foreign vendors is broader than only SBIR. Is really
fine.
what type,
sure.
Doesn't exist for foreign vendors, so obviously, if you need to work with the foreign vendor, you have to find other ways to fund it.
Yeah, right. So anyway, I mean, we are now talking about using funds which we get for our essentially for experiments talking with Hamamatsu, with a large company, you have to somehow promise success. You know, you have to, they make a calculation how much money they make, and that will dictate their engagement with you. And so with Hamamatsu, we found that we had to actually prod them. We had to go in and show them the data which we get from smaller companies, from detectors from smaller companies, and show them that they work. And we had to show them also that there was a way to get to a large offer in an experiment. So that is clearly an issue. And with Hamamatsu, it was a little better because we had this relationship for 30 years or something like this. And so in between, we had actually fairly large orders, like for space or for accelerator use, so that they would talk with us. But otherwise, I think it would be very hard. So that's where these smaller companies come in. You know, Julio is not here anymore, but CNM or FBK, you know, small companies in Europe. And what I found is that having another organization between you and the vendor helps, right? So we are talking about, you know, groups like RD50 at CERN, which has, you know, 60 or so universities or labs, and they can pool their money, they can pool their power, they can make long-term arrangements with the vendors, and then suddenly it becomes possible.
And I think perhaps also Steve and Juan can comment on how they handle the relationship with DALSA. We heard previously about how work well and some difficulties.
Well, there have never, other than these government acquisition rules, there have never been any issues with DALSA in terms of procurement. I think that may be because they're Canadian and they're nearby. But in terms of Maurice's question, funding challenges, development with foreign vendors, we didn't have that problem. And I suspect it's because they're Canadian and you know, in the early days, I didn't even need to get any special approval to visit Canada because from the government's point of view, it was not a foreign country, but that has changed. So yeah, I don't, and in my experience with DALSA, I haven't had that issue at all.
Juan, do you want to comment further on that?
No, the way it works for us is that really Steve works with DALSA and we work with Steve, right? So all that part is really on Steve's side.
Okay, so it seemed clear from your presentations early in the morning and also the personal introduction that it's key to have a sort of integration, collaboration with companies and very often small businesses. Do you see another model, or this is a sort of a general model that we have to assume, and also we should consider how in each case there was a bigger motivation for each of these companies to get involved in the partnership? In other words, it doesn't seem that we have a sort of vendors type of relationship as a model. It always involves a very close collaboration.
Well, certainly in my experience, working with the smaller companies is more straightforward. I've had some experience with a larger company, but they tend to be more secretive and less sharing. And I do think it's true that the smaller companies, there's an easier input into those companies.
Michelle, you wanted to add something?
Yes, you know, it's actually an interesting question which has come up with our new cross-cutting initiatives folks. And there is a question about whether there might be a possibility of developing a set of vendors who could support given communities. But I don't really know how, you know, how that would quite work. The question was asked whether we could create a catalog, and I responded about that in the chat if people would like to look at that. That ends up creating what's called a system of records in the federal government. And I was very dissuaded as I said, well, you know, would this work? Or does that flirt with trying to be maybe giving someone an unfair advantage, or the federal government endorsing someone? And my director looked at me and said, yes. So I've had that idea. The best I can do is far and wide, you know, let people know, hey, these awards were made. You know, you can call these people up. They'd be very happy to talk to you. Maybe do an NDA. And I've actually seen that happen. You know, I get feedback. So that's my recommendation there in the near term, at least working within the SBIR program.
Okay, thanks. We have another question in the chat that is from Kimberly to perhaps mostly Anna. So, how large a company has ever been partnered with, and what issues have arisen? Have market forces ever kept an idea apart from the physicists that could use it or develop it?
All right, so I would like to add, and also maybe as a transition to what you were discussing, that it does seem that working with a small company, it's a little easier. There is certain flexibility, and you can have a meeting, at least before you could have a meeting face to face, and it could include then all the necessary people from that company. On the other hand, sometimes working with a large company, if you can get them interested in the project, it also has normally it depends then on how they are structured and how much also independence, let's say, maybe a particular sector will have. There's always, for them, I think it's also a matter of being able to say that they are doing this for a national lab, this work, and that has always, so I have had good experiences both ways with them. And then regarding to the question saying what issues have arisen. So sometimes, so the biggest issue that comes, particularly with the plastics industry, is the amount of product that they produce is huge. It's really, you know, it's compared to what, so we go there sometimes, so we are dismissed as being too small, all right? So normally, often is that even when it's a large, what we think it's a large amount, for them and ends up being really minor. And on top of that, we go there with lots of basically demands. We want it to be clean. We want it to be still inexpensive as what they, so they are normally, so if it's a company that makes a product, they are normally used to work with so in extrusion. Obviously, if we were to talk like pharmaceutical, it would be a different thing. But for example, a plastics company, they are going to be making parts that are going to be fairly inexpensive, and their margins are not really very large. So when we go there and we maybe in our specifications and demands that increases their scrap rate. And that obviously has to translate in cost. So it makes them very uncomfortable to really quote an expensive part when they are maybe making, let's say, corner guards or garbage bags, which are, you know, at a very low cost. So that is the first step, is convincing them and finding a middle ground. And the thing is that they are true, because we want we don't want an inexpensive price. We do want the price that's right, but obviously we are interested in as keeping the cost down too. But we cannot accept certain things. So yeah, that compromise I think for a big company, then it's just easier to say, not interested. We are going to continue with our main products, and we'll reject the.
And Anna, during your introduction, you mentioned something along the lines of different timeline models. How did you manage to have this work well at the end? Because I also seen in my experience that there are different expectations in terms of how things are developed in time when you talk with a big company or a small business versus a research institution like a national lab, a university.
Yes, it's always, if I understood correctly, it's always easier when, so for us, we always start with some prototypes and some development work. And then it almost feels like you are showing them the carrot at the far end for that big production. Still, then you have to go for requests for proposals, and it has to be bid out. So you do sometimes some prototype work with one company. The bigger job, it will still have to be bid out. So that to them, it's also a risk, because they cannot necessarily just say that they don't want, so that you cannot really work with anyone else. And yeah, that also, it's another thing it's another ground for tension, which encourages, I think, the researcher to kind of maybe check multiple companies, but sometimes funding is tight, at least in a national lab in a project like that. So did that answer?
Yes, yes. Is anyone else who wants to comment on the same question for Anna?
I would like to, I don't know how to raise my hand, but I sort of wanted to tie this in with the next question of Maurice. Namely, I think it comes back to having a network or collaboration or consortium or so, some structure which has on one side institutes, on the other side suppliers. And then, you know, the relationship is constant. If you have to do this by your own in a small, even in a large lab, and you talk with a supplier every 5 years about something or so, I don't think it works. But having an ongoing thing, and I'm thinking now about an example like RD50, which is there for 20 years or so, you really get to know these suppliers. You really know what they can do and what you can ask them. And there is also a lot of trust that you actually tell them the secrets which you just found. With a big company, that's almost impossible, I would think. There, with a big company, you have to go in and you actually have to show them the path to profit. Otherwise, you are not going to go anywhere. So you need these small companies anyway to get that far in your R&D, so that you can actually attract or contact the large company. So I believe that one needs, and I think correctly Maurice mentioned, uses the word networking. You need some sort of structure which is there all the time, even if you are not develop a new part in 1 year, but then the next lab over will be doing it, and that I think will help you to have success.
So let me read then Maurice's question
Yeah.
that is relevant for many others. So Maurice rephrased a bit his earlier question and is saying, networking seems essential in order to get going. How can we implement a matchmaking mechanism for new scientists to get started with the right industrial partner?
So I'd like to throw in my my thoughts. So I actually ended up skipping over a slide by accident about our exchange meeting, but there's a couple of mechanisms. One is we have an annual exchange meeting, which Gabriella has spoken at, and we ask the whole community to come out, and these are academics, they're from the national labs, and the labs, which tend to have the bigger budgets, send people. But even labs budgets for travel are, we're have pre-COVID pretty stressed, and of course, in COVID, nobody's traveling. This year I did the meeting virtually, and I had the largest attendance ever because there's no problem with getting a room, and it was quite nice. I may always try to keep some sort of virtual presence that way so that people can attend. That is one way, and we're really trying. I'm trying to get the new scientists, and I'm working with the leadership in our different academic, or what we call our centers of excellence, and also our labs to get young scientists involved. The other possibility, I've seen this done at Jefferson Lab, and I don't know, maybe I just missed it somehow at Brookhaven, but the national labs have the opportunity to have industry days. Do you know, Gabriella, whether Brookhaven had such a day?
It's not quite an industry day, but we do have some initiatives to get in contact with industry, but not at the level you're talking about, yeah.
But these day-long industry days are a fantastic opportunity, and I think that's a possibility that would work with all the labs, all of our facilities, and again to get this working. It takes time, it takes effort, it takes people to be enthused. I'm certainly enthusiastic about that possibility, but we at the labs, I mean, we at DOE don't want to be prescriptive to the labs. It really has to be, we could, I can talk to individual scientists. What do you think about that? And so that'll be a question, but I see that as a possibility as well.
Yeah, one thing that we are doing is in our Discovery Park, creating an area which acts as a sort of incubator for working more closely with companies. So that's another thing we are working on.
That is fantastic. That's great.
So I think that I noticed during your presentation, Toki, is that you really highlight how relevant was to speak the same language. You mentioned at one point that you talk with one engineering in the superconducting area, and he was using the right jargon, it was very easy to communicate. Was that necessary to start talking? Did you just reduce time? Because we know that we've been talking about that in the past couple of days, how also the different background and different communications create an additional barrier. So can you comment?
Sure. I think that actually was very crucial for the success, especially I started out with LDRD funding and then moved on to SBIR, both of which have a relatively short time scale to show success, say 2 years for LBO LDRD, and the SBIR phase 1, so we can move on to phase 2, is 1 year. So with that time constraint to show something, yes, being able to communicate and be like, I know what you're talking about, definitely was the key element to success.
Yeah.
And then if I can speak a little bit to the networking.
Please.
Yes. Of course, matching scientists to industry is very important, but matching industry to scientists is important. And now Helmut joined. So I can say that he's been very actively reaching out to scientists like us. And that's a great way actually for me to find out what companies are out there. And yeah, it's great. And that I get those emails, and I find those very helpful.
Good, because I plan on continuing to bug you guys.
Yes. And another thing is that that I wanted to share is that there are some people in let's say low temperature detector community which are if I don't want to use this kind of negative word, but skeptical about the company's ability to deliver these things, because to them, to researchers, it's like, well, we worked decades on these things to finally get here. How can these companies catch up so quickly? To alleviate the kind of concern, or let the community know that these companies exist, I attend Low Temperature Detector Conference. This is one of the kind of well-known international conference for the low temperature detectors. And then they hold a special session. It's very small, only maybe 2-3 talks per conference, but they hold a special session for the kind of commercial partnership, the commercial partners. And that's being a great place where, for example, I was able to present my relationship and how it worked with the SEEK on the detector R&D. So the opportunities like that has been very kind of helpful to kind of get rid of this sometimes skeptical eye that people have on how industry can actually make fundamental science detectors, which some people don't view it as a avenue to make these detectors.
Yeah, I had to say that I observe also in other areas some skepticism. So I can imagine that there is also a bit of not being very familiar with the company, not having direct control on what the company does. So this may be also aspects that add to the skepticism in the community. So I wanted to ask one following from his introduction. He made a couple of cases where you said companies who, I quote you, are willing to change products according to our needs. Can you comment a bit more on that?
Yes. So in the case of this Q Tools company that sells some basic tools for entangled photon sources, we first purchased order what they had, right, and started using that. But then talk to them about some modifications so that it will be optimal for our Skipper CCDs application. And they are willing to actually do it and modify a little bit what they have. So the fact that they are a small company and the main people in the company are, professors from the university helps a lot to talk to them in the same language and to get them excited about new things, right?
Yeah, yes, thanks. Another thing I wanted to bring up, and that was mentioned earlier by Michelle, the concept of co-funding. We are one of the driver of these meetings has been multidisciplinarity. So maybe if you can expand a little bit more on that, Michelle.
The co-funding opportunities? Sure. So what happened around 2018 was that a decision by General Counsel was that that we had to, each office had to not just allocate the required funding levels, but they had to actually spend it. They actually had to encumber it. So since the amount of dollars that we have to actually send to the SBIR office are not in unity, are not integer values for the amount of funding asked for, you end up with slop, we'll call it. They're round off errors. You either don't have enough money, or you have too much. In the past, the SBIR office sort of took care of that, but now it became imperative that each office had to show that they had spent down their amounts. So what you're allowed to do is, these are in the complicated language of government speak, control lines, but we're allowed to somewhat cross lines if for example, Ken and his team of technical topic managers, let's say it's an electronic, they need fast ASICs, or fast digitizers, we need fast digitizers. And if a particular company has something and we have money left over, I chose to take out a slide. SBIR across the Office of Science is not all done. Not all 6 offices have SBIR at the same time. It's spread out through the year. Well, in two sort of tranches, so to speak, 2 groups. And HEP is in the second group, release 2. So I may have money left over in the summer, particularly as the grants are actually negotiated, and I can turn around and co-fund with Ken and his TTM, and we've done it. We've done ASICs, we've done lasers, it's a number of things. This is a real advantage because for a lot of businesses, in the past we sort of encouraged, try to get the maximum amount of money, that the FOA allows. But a lot of times companies say, well, I don't really need that money. I don't need that much. I can do this job. I can do this job for $800,000. And that's honest. And so then I have nominally 200K left, but that's cool because I can then turn around and co-fund HEP or FES, or within our own group, I can co-fund BES, or BES can turn around. I have one that's really hot that I really want and that I think others could use, and I'll promote it. So we get around the room, get around the table, and we pass proposals around electronically, and we talk it through. It's fantastic. I really love it, actually. A lot of people see it maybe as a pain in the neck, but it exposes it across communities. We have a really cool one with Oscar that's actually involving Brookhaven, with a company that's actually putting machine learning on top of a front-end electronic for S-Phoenix. You may be involved in that one, Gabriella, I'm not sure, but it's fantastic. And it's an Oscar proposal, but I'm co-listed as a secondary PM. I get the reports, I forward them on to the necessary program managers. And we let our community know about that, so that again it promotes the company and it promotes the opportunity. I hope that's sort of explained.
Yeah, no, absolutely. Sure. So before closing, I would like to give the opportunity to everybody to make a comment. But before starting the last round, I want to point out a comment that Isar Mosafanezad, I think is the CEO of one of the small businesses, made with respect to the MP exchange meetings. Isar, do you want to expand a little bit on that? Do you want to make any comment?
Sure. Hi. Thanks for having me.
Would you like me to? Oh, good. Sorry.
Did you call me, Gabriella?
Yeah, Isar. Yes, please go ahead.
Okay, great. Yeah,
very quickly though.
Put a chat comment there too, and Michelle very nicely responded. For us, again, we've been in business a few years now, and so it's been great for us to connect with other businesses. And in fact, we've worked with detector companies. Also, we even work with Incom that came out of these meetings essentially. So we are now proposing microelectronics that will match the LAPPDs and their in fact, their capabilities essentially. So that has resulted in funded SBIR projects, and we continue to work with these other stakeholders and the national labs, also collaborators. So thanks for putting this workshop together. Great.
Thank you. So let's start with Harmut again. Do you have any closing comment?
No, I don't.
And Harmut, Sadruzinski, you're muted though.
I want to have Helmut the chance to also say something. Anyway, I believe that we still need some more, of this, what Maurice says, networking, which really gets the different institutions to work with each other, even if they're not working on the same directly on the same project, and get more of the ideas of universities and labs together and start thinking about it. I think SNOMAS, which we are now doing, I think is really a big help. There are a lot of LOIs for SNOMAS, which have several institutions which maybe never have worked before together and now are coming together. I think it's a right way to do this, to get people actually to get out of their experiments and getting into R&D activities.
Thank you. Steve, any closing comment?
I guess I'd like to say, I thought this was a very interesting meeting and worthwhile. And I'd like to maybe comment just a little bit on the SBIR, because I've been around for a while. I've been reviewing SBIRs for a long time, and I think the program has gotten much better over the years. And I'm seeing, especially like Toki's work, where really making impact. It's really helping out the national labs, I think, more than it did in the early days. So I'm very enthused that things are going so well with the SBIR program. So I appreciate all the efforts of the people working hard on that. I think it's really paying off. So that's my comment.
Thank you. Juan?
Yes, I will like to say that this meeting has been great, and it's good to see all the possibilities to work with industry, all the things that have worked successfully, and really gets me excited to push for more of these connections in the future, right? Thanks.
Thank you. Toki?
Yeah, right. SBI program has been tremendously helpful for my R&D, especially I'm still a kind of early career scientist. So without that, I don't think I could have done what I've done so far. I'm always curious what companies are out there. So some were more structured to kind of let us know what companies out there that's interested in working with scientists. If I get like a list of that would be a fantastic thing to have.
Anna?
I just would like to say thank you for the invitation. Hope I have been useful to the rest of the group. I would like to add that, yeah, I do think the SBIR program is definitely important and very useful. It seems to always have lots of applicants. And I have tried once convincing a company, they didn't really go for it, but actually I worked with a company many years ago that I think that very early in the SBIR program, and that they did go and had success. So anyway, it's good. It's good that we have that available.
Thank you. Ken?
So let me just comment that there is a sort of side door way to make connections with new companies that you're not working with, and that is in our annual call for topic language. So I can give you several examples of topic suggestions that came from national laboratory groups that had a mission need and a particular technology that they did not have access to. We put their topic language in, and we got responses from companies that in some cases they wouldn't have thought of, some cases they did know, but in other cases they didn't know. So if a particular company responds to your topic idea, then that's a way to make a connection. And it's a great way, by the way, because they have to put a proposal in and it has to be reviewed to make sure it's really going to do what they say it's going to do. So that gives some credibility to the company to survive the review process. So keep it in mind, and you don't have to wait for our call for topics. Michelle's comes at a different time of year than mine does. So be thinking of it. If there's a technology piece you're missing, start formulating it into topic language that might be able to go into the SBIR topic.
And topics are available on the web at the SBIR STTR office, both for release 1 and release 2. So you can go back and look at Ken's compilation from his team and or mine or anybody else. I guess maybe some of BES or FES might be useful to you folks. But for example, I always download Ken's topics so that when I start working on my own topics with my team and with the community, we look to see what's synergistic or what's being really handled by HEP. It's really important, but they're all out there, folks.
Thanks, Michelle. Do you have any final comment?
Again, I have to add my thanks for being permitted to join this great community. I'd like to attend every year if you want me to. I mean, I don't have to talk, but I'd like to be invited to at least know about it. I'm getting ready to send my email address, unless it's easily available to the participants. If you'd like to be added to my distribution list for the awards for phase 1s and phase 2s, shoot me an email and I'll add you to our community list. And the same thing, I can't offer this to small businesses that are out there, but if they have an NP award, they can certainly go, an NP phase 2, they can come to the meeting. But for folks, you know, I'm looking across the group that might want to attend the meeting that are from the communities, you know, HEP community, and like to come to the exchange meeting, send me an email and I'll add you to my distribution list. And so I'm putting that up. How long will this chat remain live? Probably not much longer, right, Gabriella? Okay.
No, we are running out, but we are happy to share this information. Yeah. Yeah.
You can do that for us.
Yeah, just send me the link. I'll add it to the agenda.
I just sent it.
Yeah, thanks.
So I know we are a little bit over time, so I want to thank all the panelists. And as this is the last event of the MultiHEP, I would like to give the chance to Maurice to close the event.
Oh, thank you for the honor. Yeah, there's. I think it was pretty good that we had this meeting. It's a SNOMAS pre-meeting, of course. So we will be putting together a report, and it sounds like people want it to be a feature that repeats. So we'll probably have follow-ons at some point. This was not part of a series right now. It was just organized as a single shot, and as part of the SNOMAS process, but to collect information. So we will make kind of reports of what we learned here. But it sounds like there's more to do in future meetings. And thank you everyone who participated. It was very nice.
Thanks, Marius.
Thank you.
All right.
Bye.
Bye-bye.